Hi everyone, welcome to Zmotion Technical Support. Today, let's see information about PC function library encapsulation. As we all know, Zmotion provides uniform API function library. It includes many kinds of host computer programming languages. And in our support article, some related PC function encapsulation knowledge has been introduced in series article of EtherCAT Edge Programmable Industrial Motion Controller, and it can be viewed in the Zmotion official website. Now here, let's begin PC library encapsulation learning. At first, learn these online commands. One is the execute buffer method. Send character string into buffer. Then controller gets the command from the buffer to execute. Another is the exile director command, director method. That is, the command is sent to controller directly. From these two, it can be seen the exile. Actually, it is the auxiliary library that provides encapsulation for motion and basic parameters with open source code method. You can check our source codes for details. Therefore, the exile library uses the basic commands that is above two methods to send them into controller. And the corresponding functions all can be referred from the basic menu. If an encapsulated command is used, or you want to encapsulate your own function, also through buffer or direct way, to send required command character string. For direct way, it executes one single variable, array, parameter-related command, and all parameters must be specific values. Therefore, some character strings cannot use direct way. Now, it can be seen there are four parameters for direct way: controller handle, command character string, returned character string, returned character string length. For buffer way, it can execute all commands and expression can be as the parameter. Compared to direct way, obviously slower and with same parameters. Okay, next, let's see one example. Set axis speed and is encapsulated in the library. Actually, it is a command character string that equals to this. Next, encapsulation steps are shown. Firstly, open the source code of auxiliary library and add corresponding function. This is the role definition. The maximal exit number. If the parameter is bigger than the max number, an error will be returned. Then, generate the speed command character string. Send it to controller to execute. Secondly, new add function definition in the exile FLL point def. Thirdly, add a related statement in head file. The last, compile and generate new DLL. Okay, next, let's see how to get several kinds of data directly. Also, from one example. If you need to obtain exit demand position, exit feedback position, I/O, this kind of so many types of data, and then use current method to send. It needs several times of sending and receiving. It will cause host computer program blocking. So we can define only one command, that is, send the character string once or data obtained once. In this way, it's faster. If there is one 3-axis platform, depose, unpose, and axis status of axis 0, axis 1, and axis 2. And in 0 to in 32, from out 0 to out 33 are required. Here, the source codes. This is the command process function. If the command fails to execute, error code will be printed. Then, reason can be checked easily. Here is a customized function to gather data. Firstly, detect input parameters. For unreasonable parameters, it will return directly. This means generate a command character string. This means printable. Print the data, then splice depose. This part is to splice and pose. Splice access stat2. Splice in character string. Splice out. Then, after spliced, we'll send the whole character string through align command to controller once, which means no need to send one by one. The efficiency is improved. Therefore, it can be concluded strings are obtained, namely depose and pose in out. Then, through the function, convert them into floating. Assign this floating to corresponding parameters, then splice, that is, output. At this time, function encapsulation completes. Next, call the customized function. Define one controller IP to connect to controller. Success or fail, corresponding message will appear. Next, the calling. Let's run it. Here, it shows fails because of invalid controller IP. Let's use RTCs to connect to simulator. And here, the fielded IP is simulate default IP. We need to set values for depose and pose through manual motion in RTCs, because they are 0 now. Okay, run again. And it can be seen both data are consistent, which means data are obtained correctly. In and out, we didn't give the signal, so they are 0. Also can be set through the simulator. Then, it can be seen also corresponding. So this kind of customized encapsulation function is convenient and fast. Okay, now today's knowledge is over. Thank you for your watching and see you next time. Have a nice day. Bye.